Hey everybody, welcome to Chem. We're going to do an example problem using the ideal gas law. Here is what it says. A 4.22 mole sample of a gas at 1.22 atm is in a container at 305 Kelvin. Determine the volume of the gas in liters. As always, what I'd like to do is write out my variables first. So here we go. P, B, N, R, and T. Okay, and then I like to fill in what I have. 4.22 moles, that's my N value. 1.22 atm, that's atmospheres, that's pressure. 305 Kelvin, that's temperature. And then it says determine the volume. I'm going to put a question mark by V. Your R value, that is your constant gas value. There are two of them. Make sure you choose the one that contains atmospheres because that matches your pressure unit. That value is 0.0821 liters times atmospheres over moles times Kelvin. Okay. Your formula for the ideal gas law is PV equals nRT. And now all we have to do is sub in what we have. So for pressure, we have 1.22 atmospheres. I'm just going to put V for volume because that's what we're trying to find. Our N value is our number of moles, which is 4.22 moles of our gas. Our R value is that constant, the gas constant, which is 0.0821. And then our temperature was 305 Kelvin. Okay. I don't like putting too many numbers in my calculator at the same time and then trying to divide. So what I'm going to do first is clean up the right side there and multiply all those numbers together. So let me get my second line here. 1.22 atm times my volume. And I'm just going to highlight it so I know what I'm trying to solve for here and I don't lose it. And when you multiply 4.22 times 0.0821 times 305, you get 105.67. And when you multiply these numbers together, you lose some units. They just cancel, and you cancel moles, and you're going to cancel Kelvin. So the leftover units you're going to pull down are liters and atmospheres. Okay. In order to isolate the V on the left, we're going to divide each side by 1.22 atmospheres, or ATM. And when you do that, atmospheres, 1.22 atmospheres cancels on the left. You lose those atmosphere units on the right, and that's a way to check yourself before you wreck yourself. Why is that? Well, you're ending in liters and you want to solve for volume, and that makes sense. I'm going to pull down my V here, and then 105.67 divided by 122 is equal to 86.62 liters.